Hello, welcome back. This is 8-3 and we're talking slope fields. We're going to go ahead and look at another example of a different slope field and how we solve the differential equation to that corresponding slope field. All right, so example 5, here we have a differential equation y prime is equal to 1 over y, and they want us to draw the slope field in the dot coordinate plane at the right. And if you look at this, maybe you're like, oh man, like those are a lot of dots. I have to calculate the slope. But for this one, it's actually pretty simple. Our slope is 1 over y. So I can take the y value, right? And I'll take this case here. The y value is 1. So 1 divided by 1 is just 1, right? So that's what our slope looks like. And the great thing is that it's going to be exactly the same, right? For all of these dots, the slope is going to be 1 because the y value is 1, right? And so for all the y values of 2, well, it's 1 over 2. It's 1/2. Okay, so those look something like this, right? Rise 1 over 2. Okay, and then up here at y equals 3, 1 over 3, right? They all have a slope of 1 over 3. So a little bit more flat. Okay, so here is our slope field. And then similarly, okay, at 0, right? All of these are going to be well, actually, I don't have dots there, right? So 1 over y, I can't. That's non-differentiable. The world will blow up. Can't do that. Okay. How about -1? 1 over -1. Well, it's -1. So these look something like this. All right, that's a slope of -1. And again, how do you know that this is -1? Well, over 1, down 1, right? And you can imagine if I make like a dashed line like this, right? Those are a slope of 1, right? So that's kind of what I'm doing. You can use other points if you need to. Okay, 1 over -2, that's -1/2. So like this. Okay, and -1/3 again, more flat. All right, so there is the slope field. Part B, it says graph the particular solutions passing through the points -2, -1. Okay, so that's this point here, and 2, 2. So I have, okay, I'm going to go ahead and be parallel to my slope. So parallel to the slope field. All right, so it looks something like this, right? And then coming up here, and we're non-differentiable at this, right? So it's going to be something that looks like this, and I'll go ahead and do the second one at 2, 2. So 2, 2 is here. So again, there's my function, and non-differentiable at 0. All right, and there's my function. Remember, and it has to be a function, okay? So you can't like keep going, right? You don't want to do something that looks like this, right? That's not a function. It doesn't pass the vertical line test. Okay, so just keep that in mind. All right, then part C, solve the differential equation. So my differential equation is y prime is equal to 1 over y, which we know that this is dy dx is equal to 1 over y. We'll go ahead and multiply both sides by y, so we get y dy is equal to 1 dx. Okay, we can go ahead and integrate, and we will get 1/2 y squared is equal to x plus c. Okay, and then we'll go ahead multiply both sides by 2. So whoa, computer's freaking out on me. Y squared is equal to 2x plus c2, and thus we get y is equal to either positive 2x plus c2, or it could be a negative root, right, depending upon the point. Okay, so 2 possible solutions there. All right. So now they want us to go ahead. Part D, it says write the functions as particular solutions for the differential equation that pass through those 2 specific points that we just looked at, right? So again, I used blue for our first point. I'll go ahead and do that again. Now notice the y value is negative, right? So we're going to utilize this function. Okay, so -1 is equal to negative square root of 2 times negative 2 plus c. Okay, so I'll square both sides, and we get negative 4 plus c. c2, we can call it just c, and then solving for c, we'll add 4 both sides. So c is equal to 5, okay? All right, so here is your first equation. Y is equal to negative square root 2x plus 5. There's your first one. And then for the second equation up here, which I did in green, okay, passing through the point 2, 2. Okay, again, the y value is positive, so we're going to use this equation. So 2 is equal to the square root of 2x plus c. Square both sides, 2x. Sorry, I forgot to plug in 2. It's 4, Schwarberg. 2 times 2 gives us 4 plus c, and thus c is equal to 0. So y is equal to the square root of 2x. And there's that particular solution. Okay, so that's differential equations and slope fields combined. Now what we're going to do is look at some multiple choice questions on the next ones and try to find the answer, okay? So here they want to know which matches the slope field at the right. So let's just go ahead and look at some process of elimination. Here for y prime equals x, okay, based upon my x value, that's always going to be my y prime. So here if it's 1, okay, maybe this one, right? But then all of these would have to be 1. And do you see how those are kind of going more steep? So those aren't, that's not the answer. I can cross that one out. How about y prime equals y? Well, all of these would have to be 0, right? And they're not, they're about 1. So I can cross that one out. Okay. How about x minus y? Well, 0 minus 0 at this point, right? That kind of negates that option. So right away, I can throw that one out. And then we have these two options. So again, we'll look at e. So 1 plus x squared. So again, say this is 1. So 1 squared is 1. That gives us a slope of 2. So say that is 2, right? It's going to be exactly the same because none of these x values, right, will change. Okay, and that's not happening. The slope is changing for those. So this is not your answer. And that leaves D. So you'll notice, right, all these slopes are the same for all of these y values. So that makes it kind of seem like, okay, regardless of the y value it's going to be the same. Regardless of the x value, the y value will be the same. And if I plug in 0 here, I get 0 squared plus 1. It gives us 1. Okay, and it's the same, right, for all of these values where y is equal to 0. Okay, and again, same here, right? If I plug in 1, 1 squared is 1. 1 plus 1 gives us 2. So all of these y values have a slope of 2. So D, boom. There's our answer. All right. And then example 7, same kind of game. Here they want to know the slope field for a certain differential equation shown at the right, which of the following could be a specific solution to the differential equation. And kind of here, just your knowledge of the functions comes into play. So we'll look at A, y equals e to the x. Well, that is an exponential function that looks something like this. Does that match that slope field? No, it does not, right? So I can throw that one out. We'll go ahead and look at C, y equals negative e to the x. Well, that's just a reflection. It looks something like this. I did totally miss my y-intercept there. Okay, which does it match? No, it doesn't. So we throw that one out. Y equals negative natural log of x. Well, I'm going to do e first. I'll talk about the natural log of x. Well, the natural log of x looks something like this. So does that match that slope field? No, we can throw that out. And then a negative one would look something like this. Okay, I mean, kind of, but you'll notice that like these don't, like the slopes, right, aren't very, very steep there. It's not matching it, right? So that can't be a particular solution there. So we can go ahead, and by now, by elimination, it's B. But you know that this is e to the x, an exponential function with a horizontal reflection. So isn't that, I'll try to draw a smooth curve. This graph here. And ta-da, it fits nicely. Do you see how that function goes parallel with all the other slopes? Boom. There's your answer, B. Okay, so just a little note, using lessons 8.3 and 8.1, you should be able to show graphically a particular solution of a differential equation and then confirm the solution by solving the differential equation, right? Just by using the slopes, your knowledge of the slope, and by graphing the function. All right, that is it for differential equations. Catch you next time. Peace out.